Hi folks, welcome to this video where we are going to take a look at the Chapter 9 hypothesis test for a single population mean, my open math homework. And so we're going to take a look at question number 4 today. They're all kind of very similar in setup, so I don't think it really matters which one we do, and we're going to take a look at number 4, okay? So, question number 4 says, according to the Carnegie unit system, the recommended number of hours students should study per unit is 2. Are statistics students' study hours different from the recommended number of hours per unit? The data shows the result of a survey of 13 statistics students who were asked how many hours per unit they studied. Assume a normal distribution for the population. Okay, so we've got a bunch of data, and you can see on the right-hand screen that I've already typed that data into StatCrunch. Okay, so we're going to need that a little bit later, but the beginning part of the question, we don't need any calculators at all. So we're going to look at these hours. All right, so we've got 13 different hours of study from 13 different students. And the question is, what can be concluded at the alpha equals 0.01 level of significance? And so when we're looking at these, I know there's a lot of words at this point in the semester, but I think as long as we keep track of what those words mean, it's not too tricky, okay? So for this study, we want to know what kind of study we should use, okay? So what kind of test we should use. So our options are a z-test or a t-test. Now, I notice in here that it said we're trying to see what that average is, okay? So we're trying to see, like, from this list of raw data, and we don't know what our standard deviation is. So we're looking at the t-test for the population mean, okay? Now, the null and alternative hypothesis. So the null hypothesis is sort of what's already been told to us, okay? And so if we look at that, we see that the recommended number of hours a student should study is 2. And so what that means is our null hypothesis means that our mu is equal to 2. Okay. So our null hypothesis is saying that that sample mean is going to be equal to 2. All right. Now, H1, this one over here, this one is our alternative hypothesis. Okay, so this one up here is our null hypothesis. Null is that sort of little 0 there, and the H sub 1 is our alternative hypothesis. And that we're just saying that we want to know, are the statistics student study hours different? Okay, so all that means is that our mu is not going to equal 2. Okay, so it doesn't really matter whether it's bigger than 2 or less than 2. We just want to know, we're just saying, is it going to be different than 2? Okay. All right. Now the rest of this, part C and D and E and F, we are going to need StatCrunch. Okay, so this is a good time to pause if you want to copy anything down on the screen, but I'm going to go ahead and delete. Okay, and so now let's take a look at this. The test statistics, or what we want to know is the t statistic. So you can see over here, I've already typed in all the data values into one column on StatCrunch. And from here, I'm going to go to stat. I'm going to go to tstat, one sample with data. Okay, because I've already typed in that data. Now I'm going to select the column I want, and my hypothesis test, I don't want that to be 0, but I want it to be 2. Okay. And then the alternative, just that it's not equal to 2. All right. I'm going to look for the p-value plot, and I'm going to compute. All right. So if we look in this little table over here, we've got a sample mean, standard error, our t-stat, and our p-value. So we've got a lot of different numbers here, okay? And let's kind of take them one at a time. The t-stat that my Open App Math asks us for, it means that our test statistics, t, equals, and then we're going to type in the number that it says for t-stat, okay? So we have negative 2.820. All right. Now, the p-value, that is also something we get from our StatCrunch calculator. So you can see that the p-value says 0.0155. Okay, so I'm going to type that in over there. 0.0155. Great. All right. Now, we want to take this p-value and we want to compare it to our alpha. So I know my p-value is 0.0155, and if I go back up to the top, I notice that they said alpha is 0.01, okay? So if I go ahead and annotate on the screen for a second, I know that P is 0.0155, alpha is 0.1, and which one of those is bigger than the other? I might notice that my p-value is larger than my alpha. Okay, so because 0.0155 is bigger than 0.1. Okay. Sorry, that's 0.01. My goodness, 0.01. Okay. Now, based on this, a comparison between the p-value and the alpha, that tells us whether we should accept the null hypothesis or we should reject it, okay? And there's also a third option, what if we fail to reject it? And those are all important things to consider. All right, so we've got our p-value and our alpha. And if we recall in our textbook, it says that we do not reject the null hypothesis when the p-value is greater than the established alpha value, okay? And that's exactly what we have here. So over here, we want to fail to reject, all right? So it means that we're just not rejecting it, but we're not sure if we're going to accept it yet. All right, I'm going to go ahead and clear those annotations. All right, and let's keep going. Oops. All right, so now we're at the stage where I know there's a lot of words, but thinking about what all of this means, right? Because statistics is more than just here's a bunch of numbers and let's, plug them into these formulas and get another number out. It is important that we think about what all of these things mean, okay? So let's take a look at our final conclusion. We have a few options here, but because our p-value is bigger than our alpha, what that means is that the data suggests that the population mean is not significantly different, okay? So in other words, I can say it is not significantly different, right? So if the p-value is less than alpha, then it is significantly different. But since our p-value is larger, it's not significantly different. So we can think about thinking it's either the first choice or the last choice, okay? And so let's read the two. These two look so similar, except one of them says there's sufficient evidence and the other one says there's insufficient evidence, okay? So the data suggests that the population mean is not significantly different from 2 at alpha equals 0.1. So that means that there's insufficient evidence to conclude that the population mean study time per unit for statistics students is different, right? We don't think it's going to be that different depending on how many samples we take. So our data suggests that this population mean study time per unit is not significantly different. So there's insufficient evidence to conclude that. Okay. All right, let's take a look at H. H says, interpret the p-value in the context of the study. Now, the p-value, if you go back to StatCrunch and you look at this picture, okay, the p-values are really saying that we have sort of these tails that we're going to be looking at, all right? So if we think about this p-value of 0.155, that corresponds to a 0.0155, that corresponds to 1.55%. Okay, so we've got some sort of percent. That's where they're getting this 1.54544 number from. Okay, but if we think about interpreting our p-value, all right, so if we were to survey another 13 students, okay, so we're getting another sample of 13 students, there's going to be a 1.55% chance that the population mean is going to be, or sorry, not the population mean, the sample mean, all right, so that word, the population mean and sample mean is going to be less than 1.12 or greater than 2.88, okay? So that p-value tells us the percentage that we're going to land in one of those two tails, but because we're taking another sample, we have to choose the sample mean, not the population mean. Okay. All right, I'm going to clear these annotations one last time. And let's go ahead and take a look at the last question here. So it says, interpret the level of significance in the context of this study. All right, so the level of significance, that goes back to knowing what our alpha level is. And alpha equals 0.01, and that is the same as a 1% chance, okay? So that's where all these answer choices are getting the 1% from. It's from our alpha value in the beginning, okay? And so when we think about what we have here, all right, if our population mean study time per unit for statistics students is 2, okay, so that was our null hypothesis. And if we take another sample of 13 statistics students, there's going to be a 1% chance that we would end up falsely concluding that it's actually different, okay? So we're looking at the word falsely here. I think that's important. We are falsely concluding that the population mean study time is not equal to, but is actually different from, okay? And so our last conclusion here is just going to be that third choice there, okay? So I hope that was helpful. Let me know if you have any questions, and I will talk to you soon.